morning, children. Welcome back to Merigiri online classes. I hope you all are fine at home. Home, stay safe. As we know that the whole world is still locked down due to corona pandemic. Dear students, the entire world is suffering lack of institution. We provided you the best software for the online classes. So welcome back, children, for the next new academic year 2020-21. Students, what are metals? What are non-metals? So generally we can say that metals are electropositive. Metals are electropositive. Then what does mean by electropositivity? Students, when we take the elements, the major classification of elements are metals, non-metals and metalloids. So here I have told you metals are electropositive. So electropositivity means ability of an element to lose the outermost electrons. When we talk about a metal sodium, a sodium having atomic number 11, when you write the electronic configuration, you have K shell with 2 electron, L shell with 8 electron and the outermost M shell with 1 electron. In order to attain the stability, the sodium will lose the 1 electron which is present in the outermost shell. So when sodium lose 1 electron means the sodium will get a positive charge. The sodium is a metal because sodium will lose 1 electron and attain a positively charge. Let us go to other examples of metals. If you take a magnesium as a metal, magnesium is having atomic number 12. When you write the electronic configuration, K is equal to 2, L is equal to 8, M is equal to 2. This 2 is extra for magnesium. In order to attain the octet in the outermost shell, magnesium will lose 2 electrons. So when 2 electron loses means it will get 2 positive charge. So magnesium also a metal. Children, then what are non-metals? So non-metals are electronegative. Electronegative. Why they are electronegative? When you take the elements, you can see there are so many gaseous elements are present. If you take oxygen with atomic number 8, when you write the electronic configuration, K is equal to 2, L is equal to 6. In order to attain the stability, oxygen should take 2 electrons. So 2 electrons should take, that time oxygen will get 2 negative charge or 2 minus. Because oxygen need to attain the stability, it will take 2 electrons. Students, if you take nitrogen gas as an example, nitrogen with atomic number 7, when you write the electronic configuration, K is equal to 2, L is equal to 5. In order to attain the stability in the outermost shell, it requires 3 more electrons. So nitrogen will take 3 electrons from other metals. So N 3 minus is a charge. Negative charge is there. So as a result, every non-metals are electronegative they are ready to accept electrons. Once they accept electrons, they will get a negative charge.
Children, do you have any examples of metals? Here I will show you some common examples. A car, a bunch of iron nail, a medals, a gold coin. Here you have a platinum ornaments and a key which is made up of iron. Students, what are physical properties of metals? Physical properties of the metals are the external appearance of the metals. So the first physical property, metals are hard. By looking at the image, you can see that here they have used iron metals since it is heavy. Even though the metals are hard, you can see some exceptional cases. Here we have the metals like lithium, sodium and potassium. They are soft metals. Why they are known as soft metals? Because which can be easily cut it by knife. The next important physical property is the lustrous. What are metallic luster? Metallic luster is the external shining of the metals. Whatever metal you take, even if you take gold, a silver, a platinum, it have a lustrous surface. Next property is a sonority. So all the metals are sonorous. You can see a tuning fork here. It will produce sound. Students, you know the instruments like violin, guitar, etc. will be based on the same principle because metals are sonorous. The next important property is malleability. So the malleability is the metals can be beaten into thin sheets. Here you can see a gold foil sheet. Students, you are familiar with aluminium foil sheet, which is the wrapper of food. You can commonly see the wrapper food like sweets and all. Okay, these are the one of the important property which is shown by the aluminium and gold since they have a malleability which can be beaten into thin sheets. And the next property, it is ductility. Ductility is the property metals can be drawn into thin wires. Students, here you can see the copper wire and the gold wire. Students, you know one thing, if you have a 1 gram of gold, you can draw it into 2 kilometers. Such a ductile ability is there for gold and silver. That is why copper is used in the wiring purpose. And finally, we know that metals are good conductors of heat and electricity. You can see in the image a tungsten filament have high melting point. Here you can see the electric wire since it can conduct electricity. So copper wire is the best example. Here you can see the electric line. It's a good conductor. Students, then what are non-metals? I'll show you some examples. You have to compare the physical property of these non-metals with the previous metals. The plastic compound is a carbon. Here you can see a rubber band and the wooden items also you can see. Compared to the metals, can you observe any changes in its physical properties? Yes. Let's compare the physical properties of non-metals with metals. Non-metals are soft, they are non-sonorous, they are non-lustrous, they are non-malleable, they are non-ductile, and finally, they are poor conductors of heat and electricity. Students, are the non-metals soft or hard? Yes, by looking at the examples, you can say that it is soft. Are they produce sound? They never produce sound. That is why it is non-sonorous. Are they shine? They never shine. But there are some examples. And are they malleable? They are non malleable. They are non ductile. And the items like rubber, wooden items, plastic, they never conduct electricity. Then they never produce any such kind of changes. Students, there are some exceptional cases you have to remember. You can see mercury here. Chemical formula of mercury is Hg. This is the condition of mercury. At room temperature, it is liquid. Students, you can see that mercury will show you a property of metal, but it is a one and only element which is present in the liquid stage at room temperature. Remember the term, this is the only metal which are present at the liquid state at room temperature. The next important point you have to remember, I have already told you that non-metals are non-lustrous. But here an exceptional case, this is the iodine crystal. Since iodine is a non-metal, it have a lustrous property. Next you can see a diamond. A diamond is a non-metal, but it have a lustrous capacity. And finally, graphite is a non-metal, but it is a good conductor of electricity. We have already studied that non-metals never conduct electricity, but the exceptional case graphite is there here. This is one of the allotrope of carbon. You can say that since the bond become very weak, it can easily conduct electricity.
Dear students, I hope you all got the idea of metals and non-metals. Let me ask you a three question. And the first question, which metal is existing in a liquid state at room temperature? And the second question, which non-metal is lustrous? And the third question, which is the most hardest substance in this world? So students, please share your answer in the comment box. Thank you.